with paper and pen, pencil.
Yes,
Okay, now you see all of you.
Yes.
This is new topic, only diagrammatic. Please, all of you, don't create any disturbance. Mute yourself and listen. Any question is there, you can unmute, you can ask. Okay. What is our next topic? Means duality. Okay. So all of you, anyone tell me what inductor will do? Inductor creates which energy? Magnetic energy.
magnetic energy.
All of you. And one topic is not done for you. It is the 4th unit. That is capacitor. Okay, capacitor, you have studied positive plate, negative plate, charges will be stored. So capacitor creates electric energy. Electric energy, for your understanding I'm saying. So capacitor. So now we say, what is duality? If two elements are having similar properties, then the elements act as dual to each other. Okay, so I'll take the example of one particular thing, all the students. So you might have seen RRR trailer also there. One person is representing water, another person is representing the fire. So two elements, water and energy, are in similar to each other. So here also magnetic energy is created by inductor, electric energy is created by the capacitor. So these two elements are called dual elements. Okay. For example, I am telling you open. What is the opposite of open?
Close.
That is switch is open, switch is closed. You can see here certain words here. Switch closed means we can say what is the dual? Switch open. So similarly, I am writing here series. This is not service. Series means what? Another opposite, another connection, parallel. Series, parallel. We are having series connection, parallel connection. Just like that one. See, all of you remember reciprocal of resistance is conductance. Resistance we know. Conductance. 10th class you got no MHO, mo. Ohms is the unit of resistance and MHO is the reciprocal of conductance. Both symbols are resistor only. Okay. Now here we say the charge magnetic field. So no need of any definition. So all of you remember what is duality. So now what you are supposed to do, I'll tell you. So one table I will show you. So now you tell me, all of you, resistance duality is what? Conductance. Okay, G it is represented. Inductance, capacitance, that is inductor, capacitor. Series, parallel. Okay, now you have to remember this one. Now we'll see here. One more thing. Voltage source, current source, all of you. Battery is called the voltage source. Okay, whenever large current flows, it is called current source. So don't get confused. One simple problem I'll show you first. So what you have to do, all of you. Now this will be entirely new. Listen carefully. All of you are able to see now one textbook. All of you.
Yes, sir.
They will give you one circuit. Okay, and you have to draw the dual of that circuit. This is the answer. No mathematical calculation, only diagram. So how to draw? I'll tell. This is the procedure. Okay. Now it is just like a simple game. You see one circuit. Now I am giving the explanation. I will read out if the words are not visible to you. This is what the entire thing, how you are supposed to do. All of you. Now on your paper, you draw all the students. First this circuit. Battery. Battery is represented by V. Start drawing all of you as this. Battery is connected to resistor, inductor, capacitor. Capacitor symbol, two parallel lines, all of you. Start drawing. Capacitor symbol, two parallel lines. Just draw this circuit. Battery, that is voltage, positive, negative, resistor, inductor, capacitor. All are connected. Draw fast. Rough diagram also neatly you draw. Yes. Now all of you, this is series circuit, right? This is series. What is the dual of series? What is the dual of series? Parallel. Okay. This circuit. So if I say inductor is there, inductor will be converted into capacitor, and capacitor will be converted into inductor. Voltage source is converted into current source. Resistor will be connected to conductance. Okay. Now this is the answer. Last one you see, all of you. This is the answer. What is the answer you see? voltage source, voltage is converted to current here. Yes sir, all of you. And next, resistor. Resistor is connected to G. G is nothing but MHO, conductance. Inductor is converted to capacitor. Capacitor is connected to inductor. Now how we'll do? This is the procedure. All of you be ready. Step 1 you write. Step 1. Okay. Now all of you listen. Anybody read out what it is visible or not? Any one student only.
Place a dot.
Right. Okay. Right. Now I'll tell you how to do this one. First, in the middle of this circuit, place a dot. All of you place a dot. All of you in the middle of the circuit. And place a dot in each circuit or mesh or circuit only. Place a dot in each mesh. How many mesh means closed area? How many closed areas are present here? Only one. So place a dot in each mesh or in closed area and place another dot outside the circuit. Outside the circuit. You have written place a dot in closed area and place a dot in outside the circuit. Two dots you have to place as this. All of you have done with that one? Okay.
Yes, sir.
Okay. Two dots. Okay. Now second step, step 2. What is step 1? Place a dot in closed area and place a dot in outside the circuit. Now second step you see, give numbers to each dot. In simple language, give numbers to each dot. So dot which you placed inside the circuit, you give the number 1. Give numbers to each dot. Give the number 1. And outside the circuit dot, you give the number 0 always. It is always 0. If this is done, anyone confirm me. Slowly you do, all of you. Relax and do. Same circuit. All of you, no need to draw once again. Here only you can write 1 and 0. For your understanding, I have drawn once again.
Sir, repeat step 2, sir.
Step 2. Give numbers to dots. Give numbers to dots. 2 dots, no, all of you. So dot which is present inside the circuit is 1. I have written here 1. And dot which is present outside the circuit, it is 0. So 1 0 you can see here. I have done here 1 0. Is it okay now?
Yes, sir.
Okay. So this, for given circuit, you place the dot inside the circuit and outside the circuit one more dot, give numbers 1 and 0. Now step 3 is very important. All of you, first you write the step 3. I'll dictate. Write the step 3. All of you, right. Mute yourself. Please mute yourself. Step 3, write all of you. Cut, C-U-T, cut each element separately. Cut each element separately and replace the element. Cut each element separately and replace the element by its ITS, its dual, D-U-A-L. Cut each element separately and replace the element by its dual, D-U-A-L. Dual means what? Inductor dual is what? Anyone tell me? Capacitor. Capacitor dual is inductor. Resistor dual is conductance. That is same symbol will be there. Okay. Now you see all of you. Better you draw once again the circuit, all of you. I request once again you draw the circuit. Which circuit? First circuit you draw, all of you. Draw fast.
Yes, sir.
Okay, draw now all of you. Now you give the numbers and dots 1 and 0. Numbering done. Fast, all of you. Okay. Now I am explaining the step 3, all of you. Okay. Ready? Anyone confirm me? If you are ready, we'll do that one. Now, if you are having any other pen, other color pen, if it looks good for you. Okay. Now ready. See all of you. Inside the circuit, you place one dot, no? Okay. Now start from the dot. First you target one voltage source, one battery I'm targeting. Okay. So we are supposed to cut this one. Cutting means what here? You start from this dot 1 and you extend the dotted lines. Those dotted lines should touch this voltage source, and then voltage is converted to current. Arrow mark symbol is the current. Current means we show by arrow mark upwards. Arrow mark upwards you draw, and it is cutting, and it has to reach the point O. Do that all of you first. So start from point 1, that is dot 1, extend the dotted lines, and those dot lines should touch the battery, and then come to this particular I. It is replaced by current I, you have to write in the place of voltage, and then connect to this particular point O, the dot O. Slowly, any shape, anywhere, exact diagram nobody will get. It might be somewhere here and around. Okay, right? It will not be neat. It will never be neat. Only the answer will be shown to you. Right? It is done, all of you. This one.
Done, sir.
Okay, now you target this second one, resistor. So what is the statement we have written? Step 3, cut each element separately. So first I have eliminated this one V, and now I am targeting this particular resistor. Cut each element separately and replace the element by its dual. Now I am targeting the resistor. So start every time you have to start from the same point O, that is 1. So from the dot 1 start, draw the dotted lines, which means cutting that element. Those dotted lines will flow through this resistor. Resistor opposite is conductance, same value, same diagram, same symbol. Symbol is shown, and those dotted lines should come and touch this particular point O. Dotted lines should come and touch this particular point O. It is done. Okay. Now all of you, now you target the third element. Target the third element, inductor. Okay. Any question anyone ask? Okay, now we are starting this one. Okay, start from the same dot and extend the dotted lines. Cut this inductor. Inductor is replaced by the capacitor, and from the capacitor to the point O. Do this one. Okay, now what is the leftover one? Capacitor. Capacitor is replaced by inductor. So start from the point 1, extend the dots. Those dots will touch the capacitor, and extend the dots, show the inductor, and come back to the point O. Okay. Now shall I move to step 4 now? Last one. All of you have done this one, cutting each element separately?
Yes, sir.
Okay. Okay, good.
Yes, sir.
Okay. Now step 4. Step 4, all of you write the statement. I'll dictate you. Write the dots separately. Write the, that is, okay, you write this one. Write the dots separately with numbers. Write the dots separately with numbers. Now you see, all of you. This one you see. How many dots we are having? Anyone tell me? 2 dots. One is 1, another one is 0. So as it is, you write here, separate it down. Below step 4, you keep the dot, and you keep the dot one more top 0, 1 and 0, as I'm showing on the screen now. Okay, 1, 0. Now you tell me, all of you, all students. First, voltage is removed and it is shown by current. Yes or no? So connect
Yes,
all
sir.
the elements. Connect all the elements. Now you see, between 1 and 0, which one we are connecting now? Current. Current source
Current.
means it is arrow mark upwards, circle. We have to show current. And next one, what we obtained? Anything you can take. There is no separate order. I am selecting the inductor. Yes or no? Inductor is connected between 1 and 0. Therefore, you have drawn here. Next, capacitor is connected between 1 and 0. We have drawn. Resistor is removed and conductance is placed 1 and 0. Okay. This one you have to draw.
Sir, again, sir, please.
Yes. See, all of you, write the dots with numbers separately. Step 4. Write the dot means all of you in the empty space, you put the dot 1, you write, and here also you put the dot 0. Okay. So what you have to do? What are the new elements you got? Tell me. First one is what? Current source. Current source you connect to this one. Okay. Second element, what you got? Any element you can take. I have taken inductor. Okay, capacitor is converted now. Here, dual. Capacitor is converted to inductor. So you must draw the inductor. Inductor is connected to 1 and 0. What is the next element? We have removed the inductor. It is converted to capacitor. So capacitor is connected here. Similarly, resistance is removed and conductance G. It is connected. Separately, you have to draw all of you. The new elements. New elements are played with 1 and 0. Now, last step is what here you combine all the things. Okay, when you combine only it becomes 1. And here it becomes only 1, 0. And you combine all the things. Just combine. That means once again you draw one dot. Just combine all the lines. Combine all the lines. It forms the new circuit. Now you can check. Voltage is converted to current. Resistance is G. Inductor is capacitor. And capacitor is inductor. Here this is series. And what is the name of this circuit? Anyone tell me? Series or parallel? Parallel. Okay. Series circuit is converted to parallel. So step 4 I am repeating. Draw, write the node, write the dots with the numbers. Okay, we have written. One is above and one is below. Connect all the elements separately. Connect all the elements separately. That is current source is connected here. Okay, with the dots we have to show. Inductor, capacitor, conductance. And combine all the dots. Combine all the elements. So all the elements are connected to 1 and 0. This is the circuit. Okay, you can take the screenshot or you can practice this one. It is only the diagram. Is it understood? Anyone? Please confirm. Any two students?
Yes, sir.
Okay, all of you. Right.
Yes, sir.
Right. Okay. So slowly we'll do the next two topics also, next class. Okay. I'm ending the session today. Okay, all of you. Right. Any
Okay,
question
sir.
is there? You can ask.
Excuse me, sir. Excuse me, sir.
Yes, yes. Ask the question.
What is the difference between magnetic field and magnetic energy?
Magnetic field. Yes, yes. See, good question. I'll tell you. I think. See, if the magnetic energy, let us say you are generating magnetic energy, and that magnetic energy is not constant. It is circulating everywhere. That circulating everywhere. If the energy is not constant and the energy is distributed or circulated at different points, then it is called magnetic field. So I am saying that for your understanding, I am giving you glass of water. If the water is placed inside the glass, okay, then it is called energy. And you are throwing the water out of the glass. So that water is occupying different places. Now that energy is called the field. Water energy is called the water field. So I repeat once again, if the energy is not constant at one place and the energy is distributed everywhere or circulated everywhere, then the energy is called the field, F-I-E-L-D. Okay, if it is magnetic energy, then it is called magnetic field. Understood? If the magnetic energy is constant at one place, magnetic field will be distributed everywhere. If the energy is distributed at different places, then we can call it as the magnetic field. Understood?
Okay, sir. Understood. Thank you.
Okay. One more student. Any question? Yes. Any another student? No question. I'm just leaving the meeting. Okay.